So let's discuss some examples of VLIW processor. The most famous example of how to probably not do VLIW is Intel's Titanium processors. It had tons of ISA features that help the compiler schedule code well, etc. As a result, the hardware of the processor became very complicated. It no longer needed to check for dependencies between instructions, but it had so many other bells and whistles to do this that the hardware was probably the most complicated Intel ever built. And yet fundamentally this is still a VLIW processor, so it's still not doing great on irregular code. Another example of where VLIW is often used is DSP processors, where DSP stands for digital signal processing. Digital signal processing does a lot of floating point work, typically in a very regular loop with a very small amount of work within each iteration and lots of iterations. So typically these types of processors on these types of codes get excellent performance and are also very energy efficient because they don't spend much power on figuring out dependencies and so on. So these are examples of when we try to use VLIW for all types of codes, we run into problems, but if we find a type of codes where compilers can do well, suddenly VLIW looks like a very, very good choice for that.